One of the biggest changes to our modern world in terms of technology has been computers. You've already looked at binary number systems converting in between base 10 and base 2. The big focus is computation in bases 10 and base 2 because different bases do exist. The book, if you read through the examples in the book, does talk about all sorts of bases. You can make a base in any number you like. Base 6 used to be somewhat popular in some circles, and we, of course, use base 10 in our world almost exclusively, and base 2, though, is the big base that's used in computers. It's used in computers mainly because you can have off or you can have on, and this allows you to measure power currents in a very simple and straightforward way. That's why computers use this. Computers entirely work by adding binary numbers. We'll use binary to mean base 2. By adding binary numbers together. They handle subtraction by talking about negative binary numbers. Now, as computers have gotten much, much more advanced, maybe you've heard of Windows 64-bit-based stuff. These things have many, many, many more commands in the processor, but at its original heart, the basic core processing command that all computers are based on is this idea of AND, which does addition. And it takes one binary number and joins it to another through addition. So let's talk about binary addition. Before I talk about binary addition, let's go back to talking about addition and how we really, really understand addition in base 10. Maybe going all the way back almost to grade school. So let's just talk about things that have 4 areas. So I've got 10 to the 0, which as we know is the ones column. I've got 10 to the first, which is the tens column. I've got 10 to the second, which is the hundreds. And then I've got 10 cubed, which is the thousands column. And similarly, in the binary system, if I do 4 places, I've got 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3, which gives me the ones column. It gives me the 2's column, gives me the 4's column, and it gives me the 8's column. So this is how I would build these things up. So if I have a number like 127 in base 10, and I'm adding this to 137 in base 10, and I'm adding these up, how do I do it? Well, I first go column by column, and the problem is when I go through and do 7 plus 7, I get myself 14. And 14 is bigger than the 0 through 9 options that I can put in this first column. So I keep the 4, and I grab this 1 and pop it over to the other side. Then I do 3, 4, 5, 6. That gives me a 6. That's a perfectly fine thing to have in this place, so I carry it down. And then I do 1 plus 1, and that gives me 2. So 127 plus 137 would give me 264. So we've got that. We have this idea that when I've got too much in a particular column, more than that column can hold, I take part of it and pop it over to the next column to the left. It's the exact same thing in the binary world. If I have 101 in base 2, and I've got 011 in base 2, and I'm adding these together, I get myself 1 plus 1, which gives me 2. Remember, 2 doesn't fit in this first column, only 0 or 1 goes there. So I can't take a 2 in this column. Instead, what I'm going to be left with is nothing in this column and an extra 1 in the 2's column. I add 1 and 1 and again get 2, which again gives me 0. I have to move things over here to the left. 1 plus 1 again gives me 2. This is trying its best right here to be a 0. 1 plus 1 gives me 2. Again I get 0 and 1. And once I've added these things together, I decide that I have this in base 2. Let's check out and see that this answer right here makes sense. From my knowledge of base 2, I've got one thing in the column that's 3 places to the left. This is 1, 2, 3, so I'm in this. There's 3 zeros here, and there's this one thing here. This equals 8 in base 10. So let's see what 101 is in base 10. Well, a 1 means I have something here in this base 4 column. The 0 means I have nothing in the base 2 column. And the 1 here means I've got a 1 in the 0, 1 column. So 101 is 5 in base 10. And then to that I'm adding this thing right here. What's that? Well, I've got a 1 in the 2's column. And then I've got, let me put that in the right column. I've got a 1 in the 2's column. And then in the 1's column I got another 1, which gives me 3. This is 8 base 10. These match up. So our understanding of addition in base 2 is just like our understanding of addition in base 10. We simply add the things up column by column, and when we get 2 full in a particular column, we get ourselves something more. Exact same sort of thing in subtraction. What do we do in base 10 when we have a subtraction thing that gives me some issues? Well, if I have 137 and I'm subtracting 128, these are in base 10, well, I can't do 7 minus 8. That doesn't work. Instead, I change this to a 2 and I borrow a 1, and then I have 17 minus 8, and that gives me a 9. And then 2 minus 2 gives me 0, and 1 minus 1 gives me 0, and I have 9 base 10. Same exact idea here in base 2 world. If I have 101 base 2, and I've got 011 base 2, well, we already know what I'm expecting to get. This is 5 minus 3. And that's going to leave me with 2. I'm expecting to get the number 2 out of here. But let's see what we get as I go through this. Well, I look over here at 1 minus 1, and that's good. That gets me 0, just like I would expect. I look over here, I have a 0. I can't do 0 minus 1, so instead I cancel out this 1, I make it a 0, and I've got 1 0 here. Now I'm able to do my subtraction. Remember, in base 2, 1 0 in base 2 is just the number 2 in base 10. 2 minus 1 is just 1, and then I have 0 minus 0, which gives me 0. So I have the number 0 1 0 in base 2. If I remember my base 2 places, I've got one thing here in the 2's column, so this equals 2 in base 10. And that's exactly what I'd expect to get if I was doing 5 minus 3. It would get me 2. So subtraction works the same way. Base 1 and base 2 are the real ones that we want to talk about. And so let's also try to talk about multiplication. Let's keep on working with our same numbers here, 101 and 011. Multiplication works in the usual way. I multiply the top by 1s, then I take a 0 and multiply it by the next thing. So I get myself 1, 0, 1, and then I multiply everything through by zeros. Add these guys up. 1, 1, 1, 1. This is all in base 2. Let's see what I'm expecting to get. What I'm really doing is 5 and 3, so I'm doing 5 times 3, and this is equaling 15. So I expect to get the answer 15 in base 10. So this is 5 in base 10 being multiplied by 3 in base 10. So I'm expecting to get this out of here. Let's see what I really have. In the 8's column, I have a 1. In the 4 columns, I've got a 1. In the 2 column, I've got a 1. In the 1 column, I've got a 1. So I've got 14 plus 1, which equals 15, if I talk about converting these between bases 10 and 11. So again, multiplication works just like it works in the normal number system. If you follow the pattern that multiplication is talking about, everything's going to work perfectly fine, just as it always would. I don't really think we talk about division all that much, but we can. If I've got And let's pick some things that actually are going to divide nicely into themselves. So let me take this 5 here, this 101 base 2. But let's actually divide the 5 into the number 10. So I'm expecting to get the number 2 out of it. How would I build up the number 10? Well, I build up the number 10 by having an 8 plus 2. So I'd have 1010. This is the number 10 in binary. I look at this 101 happens one time, and then 101 goes into here 0 times. And remember, the number 10 in base 2 is going to equal 2 in base 10. And that's exactly what I'd expect if I did 5 divided by 10. So division also works just as you would expect it to. So that is the operations in binary for addition, subtraction, multiplication, and division. Remember your idea of columns for addition and subtraction. For addition, for subtraction, remember the idea that you can borrow something from a row. For addition, remember that if you get a larger number, you can grab some of it and pop it over to the other row on the left. For multiplication, remember that you go through, kind of ignore these two for a second and do this multiplication. In binary, it's always easy because it's either nothing or 1, so I do 1, 0, 1. And the next, you do a 0 and you move everything over to the left. And of course, for 0, it's going to get all multiplied by 0 and you wouldn't get anything. Then you do addition as usual, and you can take your answer and convert it. And of course, for division, again, you look and see how many of these can I fit into some of this. I see I can fit 1. Do that subtraction, get 0. Pull this 0 down. How many times can 101 go into 0? None times, so I put a 0 up here. This gives me the answer 2. So that's what you've got.